My name is Roger Dunn, and I want to welcome you to GIS Database Field Creation. This presentation is directed at people who need to create or maintain GIS feature classes, and along with that, create the fields to track information. This presentation will tell you what questions you need to ask, and we'll go through some sample values to help you determine what kind of field you need to create. So, if you're in GIS, you're creating new layers for a reason. Somebody has asked you to create them, or you want to create them, and you want to keep track of more than just the shapes that are going to be on the map. You need to know things about them. Those shapes that are on the map represent stuff. I mean, they might be physical things that you can see with the human eye, or they might be logical things like boundaries and future projects that can't be seen yet. So ask yourself why you're creating this layer in the first place and what it is you want to keep track of. I would highly avoid making a GIS layer that's just shapes, because I won't remember, next month why I created it or what those things represent. And certainly nobody that succeeds me will know what I meant by that. So the first question that you ask yourself is, what are some sample values that the field could hold? If every feature in your GIS layer is going to represent something, you can keep track of multiple things that describe or that help you know about that asset or that feature. So list them in your head or on a piece of paper or in a spreadsheet. Along the way, be thinking of what GIS is going to do with this field. GIS can do a lot of things with database fields. It can label by them, it can symbolize off of them, it can create charts and reports, and you can also query by GIS fields. So keep that in mind while you're creating sample data. So if your sample data contains lots of numbers, possibly negative ones, maybe 0, they can include decimal points. If your sample data is all numeric, then you may need a numeric field. There are exceptions to this, but you may need one. If your sample values contain any letters at all, or like punctuation marks that don't belong in a number, then you probably need a text field. As you look at your sample values, you need to ask yourself the relationships between those values. I realize that X and Y are probably bad variable names to choose. That comes from my mathematics background, but I understand that they're also GIS coordinate values. But just bear with me here. Let's just pretend that X and Y are two sample values in your list of samples. So ask yourself, does it mean something that one of those values, X, is greater than Y? Like, does that sentence mean something? Can you do mathematical operations with them? Can you multiply them together, divide them by each other? Can you take an outside number and add or subtract them? If the answer is yes, and that question means something, then that's a high candidate value for being a numeric field. This isn't really a quiz, but we're going to look at some sample values and determine if they are a good fit for a numeric field or not. So what about quantities? You can see some quantities that I have listed here. Is this a good fit for a numeric field? Well, the answer is yes. Even though 1068 jelly beans contains a comma, the comma won't be stored in the field, but it's still a good fit for a number because it means something to subtract or add jelly beans. If you subtract, it means I'm eating them, and if you add, it means we bought more Jelly Bellies. What about nozzles on a fire hydrant? That means something. If one fire hydrant has 3 nozzles and another has 2, it's meaningful that one has more than another. And you can also multiply and divide. So if 312 students gets multiplied by 2, you've got a student influx, and that means something. What I would add, though, is that the name of the field should represent what the units of measure are. If you're tracking nozzles, then your field better have something in it that indicates the word nozzle. What about measurements of space, like those shown here? Are these a good fit for numbers? The answer is yes. These are all good fits for a numeric field. If your sample data contains a whole bunch of feet depths and square footage, hectares, then those are a good fit for a numeric field. But your field name should still represent the unit of measure, right? If you're keeping track of 6-inch pipe, then maybe width underscore IN would be a good field name. 32.5 feet wide, maybe it's road width underscore FT to describe that. Now, I would add at this point to be consistent with your data. So let's take the 6-inch pipe example. If your field represents inches of pipe width, then 6 is the right value for that field. But if you've got a 2-foot pipe in your database, or you could have one in the future, resist the urge to put 2 in that field because it represents inches. So you need to put 24 in that case. So be consistent. Now, the units of measure, such as the double quote for inches and the word hectares, those aren't going to show up in the field. You can coerce certain kinds of formatting in ArcGIS, but those words aren't likely going to show up. You just have to know. And then the 32.5, see how that's a fraction? That number will really be stored as 32.5, just so you know. Again, ArcGIS can be configured so that it shows fractions like that, but you really want to store 32.5 in that field. Measurements of temperature. Are these good examples of something you'd store in a numeric field? The answer is yes. You notice that we've got a negative, 27.2. It's okay that it's negative. Numbers can store that. They can store fractions of a degree. But your field name should indicate if it's Fahrenheit or Celsius, unless it's just uniform across your organization. I realize that Kelvin's not listed here. These are numbers because if you add or subtract 10 degrees, then that means that something's getting hotter or colder, respectively. Even though it doesn't mean anything to divide temperatures, 200 divided by 2 is 100, but that doesn't make sense temperature-wise. It's still a good fit for numeric field regardless. What about measurements of time? Are these a good fit for a numeric field? They are, but there's a caveat, right? You can't store the phrase 1 hour and 20 minutes in a numeric field. You have to stick to one unit of measure or the other. So let's say that you're going to keep track of hours in that field. Maybe this is the number of hours that it took to do a job at that GIS feature. Well, 1 hour and 20 minutes, it's not 1.2. It's 1.333333 because 20 minutes is 1/3 of 60 minutes. So you can store that in the field, but it may be difficult for you to input the data and for someone else to read the data. Nevertheless, I still argue that it's a numeric field despite that obstacle. You could say that the field represents the number of minutes that the job took, in which case you'd put 80, which is a slightly easier conversion, but it's still got to be a numeric field because it means something if one job took an hour and another job took an hour and 20 minutes. Clearly one took longer than the other. It was greater than the other. A job that took 30 minutes is half as long as one that took an hour. So all these numeric relationships still hold true for measurements of time, but you may need to do some conversion to figure out what the value means. 4 days and 4 hours. That's a long time, but it's hard to convert that 4 hours into a decimal point for most people. So what are you going to keep track of? Keep track of hours, then multiply 4 days times 24 hours, and then, do the math. What about years? If your sample values contain years, do you want to create a numeric field for them? I would add yes, because it means something for one year to be greater than another. And like the other numeric fields we've looked at, it means something to subtract years from each other. I mean, that's typically how you get age, right? 2018 minus 1974 will give you the age of an asset, the age of a person, the age of some boundary, whatever. What about phone numbers, like those listed here? Is that a good fit for a numeric field? Well, it looks like it would be, but the answer is that phone numbers are not a good fit for a numeric field, and I'll tell you why. Phone numbers don't have any mathematical relationship to each other. It doesn't mean anything to take 911 for emergencies and subtract 411 to get 500. That's not a meaningful relationship with a phone number. It also doesn't really mean anything for one phone number to be greater than another. I mean, true, you can sort them, that may be helpful in certain applications, but it just doesn't mean anything. 911 is greater than 411? Okay, so phone numbers could also have extensions, right, to certain departments or individuals within a large organization. You want that to be represented by text. Additionally, if you've got a phone number that contains letters like 1-800-RED Cross, it's kind of nice to just type 1-800-RED Cross in the field rather than translating each of those alphabetic characters to a number on a keypad. What about zip codes? If your sample data contains zip codes, are you going to want to store it as a numeric field? Well, like phone numbers, I would argue that you don't, because the mathematical relationships don't matter, for one. You can also have the 4-digit extension, which you may want to separate by a hyphen, so you got to store that as a text field. Now, one cool example is over there on the East Coast, that Boston zip code. It starts with a 0, and if you were to store zip codes as a numeric field, that 0 would just drop off. And if you were to print a mailer, well, you'd be missing that key first digit. So text fields is what you want for zip codes. What about money? Say that your sample field values are going to keep track of money. Is that a good fit for a numeric field? Yes, it is. Because it means something to add or subtract money, it means something to multiply or divide money, and it means something to compare money. $1,234.56 is clearly greater than 25 cents. Your field name, though, may want to reflect the currency that you're using, much like the units of measure for quantities and physical measurement. So you may want to put like USD in your field name or Euro in your field name, just so it's obvious what currency you're using in the field. What about part, model, or version numbers? I kind of lumped these all into one slide, but are these a good fit for a numeric field? Well, here I would say no. Part numbers may contain only digits, but often over time, as a supplier gets more and more parts, they start including alphabetic characters in them. They may include other punctuation like hyphens and periods, which help them specifically identify a part. And while with version numbers it does mean something for 10.6 to be greater than 10.5, I've seen a lot of products over the years where the version number no longer looks like a number. It gets some word to indicate what version it is. So text field all the way with these kinds of data values. Here's a screenshot from our catalog. I'm going to create a new field. You can see I've got arrows pointing to the 4 kinds of numeric fields. Text is just below that, and then date and the other 3. So let's go over the kinds of numeric fields you could create. So look at your data. You may need to create an integer field. An integer field can be negative. There are lots of times where it's 0 or a large positive number. A whole number, an integer, is something you can count to given enough time. The commas aren't stored in the field, just the numbers are. But if you're counting something, you likely need an integer. And here's an example. How many such and suches are in this feature, are on top of this feature, around this feature. Those are all integers. Age. If you want to keep track of how many whole days, months, whatever, that's an integer. Or if you're going to use measurements, it's got to be whole units of measure, entire feet, entire square feet. But there's two kinds of integers. If you remember from that slide, there's short and long. In computer science, we also talk about small and large, and they mean pretty much, I think, the same thing. So a short integer is going to go from about negative 32,000 to positive 32,000. So you want to use a short integer for things like years, smaller quantities. You get the picture. And then long integers are something from negative 2 billion to positive 2 billion. Those are approximates, though. If you really want it, you can Google the exact numbers, but those are your estimates. All right, now there are also float and double fields. A float takes up 32 bits in a computer, while a double takes up 64. Bits, as you may recall from pop culture, are zeros and ones. Doubles have greater precision, so they can measure really precisely. Doubles are so precise that that's the kind of number that's used to store coordinates in a lot of geodatabases, because you want to have a precise measurement of where the vertex or the point is on a map. I don't use floats anymore except for root beer and ice cream. Really delicious. I do stay away from parades. Maybe that's why I don't like floats. But doubles can just keep track of so much better and accurate information that a float can. Now, date fields I'm going to touch on right here, because in a lot of databases, a date field is really a numeric field under the hood. You don't see it, but it's treated like a number. I mean, if you think about it, one date can be greater than another date, right? It just means that it's more recent or further into the future. You can also add today. So if I take today's date and I add 7 days, I'm going to get a meaningful answer, which is next week. Time can also be kept in a date field, so don't let the name fool you. You can keep a precise date and time of like when something was done, when something was installed. Those are good things. But the minimum value of a date field is going to be December 30th of 1899 or 12 a.m. Different databases have different minimums, but I bring this up because if you want to store something that's really old, then you might have to go with like a string field or something. I don't know what more to say about that, but you need to be keeping track of more recent dates to have a date field. Oh, I also want to say something about unknowns. I've seen cemetery databases where there's a date field for when the person was born or passed away. That's good, except for when you don't know a certain piece of information. So sometimes a gravestone will have, 1796, but you don't have a month or day of when that person passed away. So that's not a great fit for a date field because it's going to require the month and day be entered. So there's other tricky, clever ways of getting around that. But in your GIS, maybe that's something you don't have to worry about. All right. If you've already determined that you don't need a numeric or a date field for your sample values, then you probably need a text field at this point. So here's how a text field is utilized in ArcGIS. The first or leftmost text field in a geodatabase is going to become what's called the default display field. The display field is used when you're identifying a feature, and it's used when you're labeling the feature if you don't change anything else. So here I am in the layer properties of a geodatabase layer, and I have circled here zone ID in the drop-down list because that's the first text field. So that's what a display field is, and your first text field becomes the default display field, and here's how that's used. So when you identify a feature, that display field is used in the top half of the identify dialog to show what you clicked on. If you clicked on multiple features, obviously that gets populated with more things under the tree, but that first text field is pretty important because of that default identify behavior. And then here I am in the Labels tab with the zone ID again circled. If you just right click a layer and turn on labeling, then it's going to use that default display field as well. So text fields are going to contain these kinds of contents. You have to note though that a database field in a GIS is free text, meaning you can't really enforce a pattern on it, at least with not any out-of-the-box products that I know of. You may have a field that represents a phone number, but how are you going to format the phone number? If you're the one inputting the data, then you get to maintain the integrity of the database, and it's going to be formatted just the way you like it. Formatting is important for consistency, right? I mean, if you want to find a phone number and you're looking for a prefix, that becomes a lot easier if all your phone numbers are formatted the same way. But just because your field represents a phone number, that doesn't mean that somebody else that's editing this data could put something like, the quick fox, jumped over the lazy brown dog, as long as it fits, right? So you just have to know that about text fields, that they can't kind of maintain their own integrity unless you fix it with a domain, which we'll talk about a little later. If you're going to store zip codes, you're going to include the hyphen or not. You may be keeping track of names of people too. So are you going to have one field for each part of the name? Middle, first, last, suffix, prefix. Are you going to have one field that represents the entire name? And if so, what order are you going to put the words? First name, last comma, first. What are you going to do about nicknames? Are you just going to, are you going to go off of their birth name or their nickname? What are you going to do about case? Here I've listed my last name as well as the last names of 2 Broadway actresses that were in Wicked. Our first letters of our last names are all capital, and the rest of our letters are lowercase. There are functions that can imply that sort of formatting, but there's lots of exceptions in the real world. I mean, McDonald's, needs a capital D after a lowercase c. You've also got apostrophes that can appear in a name and force 2 letters to be capitalized. So some organizations avoid this problem entirely and just require that all names be put in total uppercase letters. And then if you're going to store middle names, how are you going to do that? Just a letter and a period, or are you going to spell out the name? The names of businesses, if you're going to keep track of that in your GIS, come with their own problems. What are you going to do about abbreviations? Here's some examples here. You should decide on a format and keep it, and if you are instructing others that are going to maintain this database with you or for you, you need to let them know what the standard is. Here's some other formatted text field values that you might want done a certain way. Now another thing you have to determine when you're creating a new text field is how long it should be. So the first question, right, was list some sample values. And I initially said, do that in your head. Your new field might contain only a few possible values. That's great. But what if it can contain almost anything? Well, then you've got some, tougher questions that you have to answer. So every character, every letter, every punctuation mark, every number inside of a text field is called a character, and you need to count those to determine the length of your text field. Now here's how to use Notepad for that. Let's say that for my database, the new field that I'm creating, the longest possible value is backyard fenced area. I just chose something at random. I type it into Notepad, and I put my cursor at the very end of the text, and I look down in the lower right hand corner to see what column I'm in. I take the column and I subtract 1 because the leftmost position is position 1, and I can readily tell that my text value is 20 characters long. Now if I'm smart, I'll anticipate longer values, so I might create a field that's actually 25 or 30 characters so that things I didn't expect can fit in that field. Now you may be lucky enough to have a spreadsheet which contains a whole bunch of values that are going to possibly go in this field. Excel does not cut off the length of any text that you type in any one cell. It lets you just go on forever. So we're going to use Excel to find out what the longest possible value is. So here's a a spreadsheet called projects, and it has a bunch of text values. Now, a clever person can clearly see that cell 25 contains a really long value. I could copy that, paste it into Notepad, put my cursor at the end, and readily tell how long it is. But bear with me, I'm just using this as an example. You may have hundreds of values or thousands of values, and it's difficult to tell how long the longest one is. So here's what you do. You go to the bottom of the spreadsheet and you click in the first empty cell. And you can tell that I'm in row 33, right? So I'm going to type the following. Equals max, open parenthesis, len, open parenthesis. I'm in column A, so I'm going to do A1, colon, A, and I choose the cell above me, 32. And then I put 2 right parentheses, or closing parentheses. Now watch what happens if I simply press the Enter key. I get an error of value. And the reason I get that error is because the len function can only take one parameter, not 32 of them, unless I make it what's called an array function. So here's how I do that. I'm going to press F2 to edit the function, and the only thing I'm going to do different is on the keyboard I'm going to do Control Shift Enter, and look what happens. The number 40 shows up, which means that the maximum length of any value in those cells is 40. Now I know that if I create a text field of length 40, all of these values would fit. If I'm anticipating more values, then I can put a length of 45 or 50 or something like that. But 40 is the maximum length of these values. So that's pretty cool. And I use that with CSVs as well, but that's another presentation. One semi-nice thing about ArcGIS is that if you have not anticipated a great enough length for your field, meaning you've got values to enter which are too long for your field, then you can change the length of it, but you've got to do some things. First of all, in order to modify a geodatabase, you've got to get everybody off of it. You've got to stop any web services that are using that geodatabase, and you can only do it if you're the owner of the geodatabase. So you right-click the layer, go into Properties, Fields tab, click on the field you want to lengthen, and then you just change the length down below. Press OK, and that's done. Most of you know how to do that. But what does it impact? If you're a lot of scripts aren't going to care how long your text field is. Your web services might. Um, you may have programs that access it, third-party programs or in-house programs. So make sure that you've got clearance from all these different technologies and people before changing the length of a text field. Alright, I alluded to domains earlier in the presentation. Domains are a geodatabase's way of enforcing data integrity. It makes it so that you can only choose from a fixed list of possible values, and it's really great because you can eliminate typos. You've got a field that's easy to query and maintain. When you create a domain, it applies to the entire database, so any feature class within that database can use the domain. It is difficult, however, to enforce a sorting of values in a domain, but it is possible with an Arc Toolbox tool. And then whenever you change a domain, like adding or removing values, you need to republish any services that that are using the layers, which in turn use the domain. So here's an example. Let's say that I want to keep track of fire hydrant color, and in my city I know that I've got 3 colors, red, yellow, and green. I could store those in a small integer field as 0, 1, and 2, or a 1 length text field for R, Y, or G. I could store it as a 3-letter text field as red, yell, or gurn, or a 6-character field where I have the color spelled out. So all I'm saying is that under the hood, I've created a field of a certain type and length, but what the user sees, even if you're the user, you'll see the nice clear spelled words red, yellow, and green, and they'll be in a drop-down box. Whether you're using it online or on the desktop, the possible values are in a drop-down box. So there's no way that you or your end users can misspell yellow or green because they can't type in the field. They have to choose a value. But the downside of creating a domain is that you come across with exceptions. What are you going to do in this case in your fire hydrant feature class? If it's linked to a domain, you may have to create a value in the domain that represents other, or multi, or miscellaneous. Boolean is a type that we computer science people use all the time. It means yes, no, or true, false. So if your sample values just contain a bunch of check marks or these values I've listed here, you could store those as a small integer field where 0 means no and 1 means yes, a text field that's of length 1 or 3, or a text field that's of length 1 or 5 if you're going to keep track of the words yes or no or true or false. You should be consistent, right? You shouldn't be mixing yeses and trues or no's and falses. So basically what you do is you set up a field that's one of those types and you link a domain to it so that it says the words yes or no, true or false. But here's a caution. One of the things I've seen done wrong in practice is having a Boolean field and the field name doesn't indicate a good or the right relationship. So here's an example. So let's say that you're keeping track of addresses and you have a field called accessory apartment and it's being used as a Boolean, a drop-down list of yeses or nos, trues or falses. It's unclear to an outside person if this field represents whether the address is an accessory apartment or whether it has an accessory apartment. Another example is maybe a field called private when it's used for water lines or sewer lines. So that could be a Boolean field and that's fine, but does it represent whether the line itself is private or whether it's public but underneath private property? So name your fields well, train your end users well as to what is to be tracked with this field. Usernames are another good fit for a domain. If you've got crew members or supervisors that you're keeping track of in a GIS, like the work they do or who installs what, usernames could be a good domain. So in the domain, you would say that the value is the username, maybe one that's assigned by your organization, and then the display value is their full name. You do have to look at what happens though when you delete a username. Like if, let's say that you let someone go or they leave to go work for someone else. The username kind of has to stay in the domain because any past work that they've done should show their name as the one who did it. If it doesn't show, if their username isn't in the domain anymore, then when you look at the value in ArcGIS, it'll show the username, and you may or may not remember who that was depending on how long ago it was. But does it matter? You have to ask yourself that too. Does it matter that work done 10 years ago was done by a user whose name I don't recognize? Then it may not matter to you. It could, maybe, for liability reasons, I don't know. But it's something that you have to figure out when you're creating a field that represents users in an organization. All right, here we come to the big, I wouldn't call this a finale, but this is a major sore point for me and a lot of people when creating a field, and that is that people commonly create a field that's supposed to express what type of asset or feature it is. Type is a four-letter word, and it just can mean so many different things. So here's an example, parcel type. Well, what does that mean? Does that mean what zone it's in? Does it mean what the capacity of that parcel is? Is the type of parcel supposed to represent its purpose or use, its class or its value? Man, it's really difficult to make that kind of decision. Now, it may be obvious to you, depending on the kind of asset that you're representing with GIS, but people can really get hung up on the word type and use it in an incorrect way. Take tree type, for example. This is another database I created for Orem. The tree type represents the species of trees. So maybe that's a better name for it. It is a domain, and it has 321 values from alder, common, to zelkova, village green. And each of these has an English and a botanical name. The advantages of having tree type as a domain is that there's no typos. I mean, you really could spell zelkova incorrectly. But it's also a very difficult domain to maintain, because when a new tree type is purchased that we're going to plant, we have to add it to the domain, sort it with our toolbox, and then republish services that are attached to that. But again, we decided that type meant species. But anyway, when you are creating a field that represents a type, you've got to ask yourself some tougher questions that deal with the terms collectively exhaustive and mutually exclusive. So if you've got a list of values in your domain, collectively exhaustive means that you've thought of every possible value that one of those assets could have. And mutually exclusive means that there's not one feature in your feature class where two values in your domain could apply. So, I've said a lot, I've said a mouthful, you've probably had to rewind and re-listen to that, but I'm going to give you some example problems. So let's take function versus material. A lot of times when people think of a type of an asset, they're thinking of what it does versus what it's made out of. Those two things are not collectively exhaustive and mutually exclusive. You need to have two fields if you're going to keep track of what it does and what it's made out of. material may not be mutually exclusive. If you've got a list of materials like concrete, asphalt, and so forth, can you have an asset that's made up of more than one of those materials? Because if you can, then that may not be a good fit to have a domain and only one field representing that. The same is true for function. If something has two functions in your drop-down list of values, oh man, you're kind of stuck. You've got to figure out if you need an additional field for that, or if you're going to create a relationship with another table. But this can get really tricky. If function and material are represented by one field, then things get really sloppy really quickly, and I would just advise to split those out. People also consider type to mean make versus model. Make should be its own field, and model should be its own field. But what happens if you mix and match? Now it's not mutually exclusive, because if you have one manufacturer that never could possibly make this model of asset, well, what do? That's incongruent. It's incorrect to have those values. So maybe the answer is that make and model are put into one field, but it's both of them combined. Like Ford F-150 would be one whole value rather than having Ford in one field and F-150 in another, if you're keeping track of trucks. And then another example of where people get hung up on type is owns versus maintains. So we got similar problems there. I'm sorry I could only dedicate like one slide to this important topic, but I hope that what I've said covers what you need to ask yourself about the data that you're going to keep track of. That's all. Sharing. You have to remember that your data will likely go to other entities, whether in-house or outside. So the clearer that you can make your field names and field values, and the consistency with which you keep them, will be important to who you share it with. When it comes to databases and fields, what does null mean? And the literal answer is, I don't know. A null field represents that you don't know that value for that particular asset. Only Geodatabase fields can have null values. Shapefiles don't support that concept. A null value in a text field is not the same as an empty string. So let me give you an example of middle names. If you were keeping a GIS database and you had a middle name field and you were tracking me, then the value of that field for me would be Williams. You may have someone else who simply just doesn't have a middle name. So the correct value for that field should be the empty string. But what about if you are tracking a person whose middle name you don't know? They may have one, but they might not. It's kind of incorrect then to have blank be their middle name, because that indicates that they have none. If the middle name field is null, it means you don't know that middle name. So I hope that helps clarify what the difference is. Null numbers are useful for when 0 has a meaning. So if your GIS layer is tracking how far something has gone, 0 means it has not moved. The odometer reads 0. The meter reads 0. It just hasn't gone on. That's what 0 would mean. If it represents a length of time, like how long ago, 0 means it's brand new. Null means you don't know. So a null would mean you don't know how old that asset is. It's probably ancient. You just don't know. So a null would be a good fit. How far has that asset gone? Null means you don't know where it's been or how long it's traveled. So that's how null works with numbers. Null dates also means you don't know when something happened or will happen in the future. When you query null in ArcGIS and in database applications, you don't say, give me everything where the field name equals null. It won't return any values. You have to say where the field name is null. This is a key word, and then you'll get the results you're looking for. So if you're looking for everybody whose middle name you don't know, you would say field name is null, and you would get that list of records selected. If you're looking for everything that you do know, you do not do field name doesn't equal null. There's two ways to do it. You can ask where the field name is not null, or you can throw the not at the beginning and say, give me everything where not field name is null. This is more English, and it's supported because of that. This is technically more correct, but who am I to judge? Reporting null. When you have null output on screen or paper, oh, sorry, that's a different slide. If you're going to sum or average null, depending on the database, you'll get null as a response. ArcGIS is pretty good about ignoring nulls, so if you want to sum up, all of the jelly beans in all the jars represented in your GIS, it'll skip the nulls and just sum up those that you know. When you sort null, sometimes it comes first and sometimes it comes last, depending on the database, depending on the driver and the client application. So you have to play around with that. But there are some database tools that access your GIS database directly, and they may return a null answer if you're wanting the sum or average of a field. And then when you're displaying it, it could be just a blank value. It could be this word null with angle brackets. Maybe it shows in all capital letters. The word null is displayed in different ways. Now that's the end of my presentation. Hopefully you have learned a lot about fields in ArcGIS, how to create them, how to make the best decisions for fields to create. Anyway, I'm Roger Dunn. Thanks for watching the presentation, and see you next time.